Hey there, statisticians. What we're going to do today in this video is talk about how we're going to state a hypothesis for a significance test. Now, a significance test, you can read right here, is a formal procedure for using observed data to decide between two competing claims. These claims are called hypotheses. What we are going to do is we're going to make a claim for what we're looking for and then a claim against it. Alrighty, because there are always two reasons for obtaining an outcome. We can get an outcome completely by random chance or on purpose. Alrighty, my desired outcome can happen because of random chance or because on purpose. And by on purpose, what I mean by that is by design. By design. That's what I mean by on purpose. So like this, a basketball player states that they are an 80% free throw shooter based on their performance in the last game. The 80% success rate could have either happened because the player is actually an 80% free throw shooter, or it could have happened completely by random chance. That's what we mean by that. So we could have been 80% successful because we are practiced and skilled, or because of random chance. So what a significance test allows us to do is the player lucky or is it random chance? Okay, so what we're going to create two hypotheses. The first one is called a null hypothesis, which is H sub 0, and an alternative hypothesis or an alternate hypothesis. So the claim that we weigh evidence against in a significance test is called the null hypothesis. It's sometimes called the dull hypothesis because this is what we believe. This is, I don't know if I really want to call it skill or by chance, but this is what we are testing to be true. This is what I want to happen. So our null hypothesis is what we want to happen. And then an alternate hypothesis is a hypothesis that tests the exact opposite. This is what we frankly don't want to be true. What we don't want to be true. That's what we don't want to be true. There we go. My null hypothesis is what we want to be true. For example, my null hypothesis with the free throw shooter would be that the proportion of his shots he makes is actually 80%. The alternate hypothesis would be his proportion of made shots is less than 80. Okay, so here's my null hypothesis. This is what I want to be true. I really want this guy to be an 80% free throw shooter. The alternative hypothesis or the alternate hypothesis is that he's actually not an 80%, that he's less than that. Now, what I just showed you was an example of a one-sided alternate hypothesis. It's one-sided if we're just testing greater than or less than. All right. So one-sided alternate hypothesis, I'm going to change colors. There we go. One-sided is either greater than or less than the null values. And our null values is what we're testing for. Two-sided, a two-sided alternative hypothesis is just different from the null value. What does that mean? Greater than or less than. Okay? So when we are great AP exam tip, hypothesis always refers to a population. So my hypothesis tests are always going to refer to a population. When I am referring to my null hypothesis and my alternative hypothesis, I will always use mu or p, but it's always going to be a parameter, never a statistic. No X bars, no p hats. Alrighty, so be sure that we state our null hypothesis and our alternative hypothesis in terms of a population. It is never correct to write p hat or x bar. Alrighty, never. We use mu or p, not p hat, not x bar. Okay? And also important, well, this is all important. I don't know why I stress this. You have to state your hypothesis before you actually look at your data. Alrighty? So that way you're not your hypothesis is not influenced by the data. I'm going to make a claim and then I'm going to investigate the claim. I don't start to investigate and then change my claims. All right. So let's look at a problem to state a hypothesis. So let's state the hypothesis for performing a significance test. Let's define the parameter of interest. So don't argue. A Gallup poll report revealed that 72% of teens said they seldom or never argue with their friends. Yvonne wonders whether this result holds true in her large high school, so she surveys a random sample of 150 students at her school. So what we want to be true, what we are testing against, is the 72% that don't argue. So this is my null hypothesis. Here is my null hypothesis right here. I want this to be true. Well, what could it be? Well, it might just be different. So if it's not 72, it's going to be different from 72. This is what I don't want it to be. And then, of course, P is the true proportion of all teens at Yvonne's high school who are rarely or never argue with their friends. And I got that information right here from the problem. Okay, so I'm going to do another one with these on the board. We're going to define our parameters. Always define your parameters. State what we're looking for, and then state what we're going to test against it. Alrighty, so in our assignment, we're going to go ahead and do 1 through 8.